Have you ever looked up at the sun and wondered about the immense power it holds? It's not just a gentle, life-giving star. It's a dynamic, sometimes violent, celestial powerhouse. And today we're diving deep into one of its most spectacular and impactful phenomena, solar flares, and their dramatic dance with Earth's invisible protector, our magnetic field. So, what exactly is a solar flare? Picture this. The sun's surface is a turbulent sea of hot gas, with magnetic fields twisting and turning like giant rubber bands. Sometimes these magnetic field lines get so tangled up near sunspots, cooler, darker areas on the sun, that they snap. This sudden release of energy creates an intense, brilliant burst of radiation. That's a solar flare. It's like a cosmic cannon blast, firing energy and particles out into space at nearly the speed of light. Now imagine this blast hurtling towards Earth. It's a journey of about 93 million miles, but for this radiation, it takes only a little over 8 minutes to get here. So, what stops our planet from getting fried? That's where our unsung hero comes in. Earth's magnetic field, or the magnetosphere. Think of the magnetosphere as a giant, invisible bubble surrounding our planet, generated by the molten iron core deep within the Earth. It extends thousands of miles into space and acts as our first line of defense. When a solar flare's intense radiation and charged particles arrive, they don't just hit our atmosphere directly. Instead, they collide with this magnetic shield. The interaction is nothing short of epic. Our magnetic field deflects the vast majority of this harmful solar wind and radiation, guiding it around the planet like water flowing around a rock in a stream. Without this shield, the solar wind would strip away our atmosphere, leaving Earth a barren, lifeless world, much like Mars. So we owe our very existence to this invisible force field. But the shield isn't impenetrable. A particularly powerful solar flare can compress and distort our magnetosphere. This is where things get really interesting, and where we start to feel the effects right here on the ground. One of the most beautiful consequences of this cosmic collision is the aurora, the northern and southern lights. When the charged particles from the sun are funneled down the magnetic field lines toward the poles, they collide with atoms and molecules in our upper atmosphere, like oxygen and nitrogen. These collisions excite the atmospheric gases, causing them to glow in a breathtaking display of green, pink, purple, and red lights dancing across the night sky. So the next time you see a picture of the aurora borealis, remember, you're witnessing the beautiful result of our planet's magnetic shield doing its job. But the effects aren't always so picturesque. This same solar energy that creates the aurora can also cause what's known as a geomagnetic storm. These storms can have serious consequences for our modern, technology-dependent civilization. Think about our global communication network. Geomagnetic storms can disturb the ionosphere, a layer of Earth's atmosphere that radio waves bounce off of to travel long distances. This can lead to blackouts in high-frequency radio communications, which are crucial for aviation, shipping, and emergency services. Pilots flying over polar routes might have to be rerouted, and ships at sea could lose contact. It's not just communication. Our navigation systems are also at risk. The Global Positioning System, or GPS, relies on signals sent from satellites to receivers on the ground. During a geomagnetic storm, these signals can be scrambled, leading to positioning errors. For you and me, that might mean our phone's map app gets a little wonky. But for industries that rely on precision navigation, like agriculture, construction, and autonomous vehicles, these errors can be costly and even dangerous. And what about our power grids? Geomagnetic storms can induce powerful electrical currents in long conductors on the ground, like power lines and pipelines. These unexpected currents can overload transformers, causing them to fail and leading to widespread power outages. One of the most famous examples is the 1989 Quebec blackout, where a powerful solar storm knocked out power for 6 million people for 9 hours. Imagine a similar event happening on a larger scale today. The impact would be monumental. Even satellites orbiting our planet aren't safe. The increased radiation during a solar event can damage sensitive electronics on board. The atmosphere can also heat up and expand, increasing drag on satellites in low Earth orbit. This can cause their orbits to decay faster than expected, shortening their operational lifespan or, in a worst-case scenario, causing them to fall back to Earth. Protecting these billion-dollar assets is a top priority for space agencies and private companies alike. So, this all sounds pretty serious, right? Well, it is. But the good news is, we're not just sitting ducks. Scientists around the world are constantly monitoring the sun. Using a fleet of solar observatories like NASA's Solar Dynamics Observatory, they watch for sunspots and other signs of activity that might signal an impending flare. This field of study is called space weather forecasting. Just like meteorologists predict hurricanes, space weather forecasters predict solar storms. By analyzing data from the sun, they can issue warnings when a potentially disruptive solar event is headed our way. This gives power grid operators, satellite controllers, and airlines time to take protective measures, like rerouting flights, putting satellites into a safe mode, or adjusting power loads to prevent overloads. It's a constant, vigilant watch over our star. As we look to the future, understanding this relationship becomes even more critical. We're planning to send astronauts back to the Moon, and eventually to Mars. Out in deep space, beyond the protection of Earth's magnetic field, astronauts are far more exposed to solar radiation. A powerful solar flare could pose a significant health risk. Therefore, creating better shielding for spacecraft and habitats, and improving our space weather prediction capabilities, are essential for the future of human space exploration. We need to be able to give our astronauts a get-inside warning when a solar storm is coming. The dynamic interplay between the Sun and Earth is a perfect example of how interconnected our universe is. A storm on the surface of a star 93 million miles away can paint our skies with light, disrupt our daily lives, and shape the future of our journey into the cosmos. It's a powerful reminder that we live on a small, protected planet in a vast and active solar system. The sun gives us life, but it also has a temper, and our magnetic shield is the quiet guardian that makes life on this vibrant blue marble possible. It's a story of power, protection, and profound beauty, a celestial dance that has been going on for billions of years and will continue for billions more. And by studying it, we not only protect our technological world, but also gain a deeper appreciation for our unique and precious place in the universe. Thanks so much for joining us on this cosmic journey today. If you found this fascinating, don't forget to hit that like button, subscribe to the channel, and ring the bell so you won't miss our next exploration into the wonders of science. Let us know in the comments what other space phenomena you'd like to learn about. Until next time, keep looking up.